Hi guys, Tuesday morning. I'm about to show you the data for the Millikan drop simulation experiment where rather than find a charge of an electron, you're going to actually find an elementary mass of a washer that's hidden inside a canister. You're going to do this through multiple measurements or measurements of multiple canisters that lead to a mathematical analysis that really boils down to finding greatest common factor. So the analysis section that follows tells you how to break it down, and more importantly, how to do tests to see if your final value is the best value rather than some other value that would be close to it but not as good. So really important that you lay that all out in organized fashion and make clear why yours is the best. I'm also going to put a shared Google sheet up there for you to put your final result and then see what other people get so that we can collaborate as a class and maybe settle on a final value. Ideally, you'd all come up with the same value, but that might not be the case. So that's important you do this in a timely fashion so we're not waiting for other people, but if for whatever reason one person or two people don't submit theirs in a timely manner, just go ahead and do your analysis without it. Okay, so the next section will show me weighing or massing each of the individual canisters, as well as giving you an idea of roughly how many are in there based on shaking them, which is something you would be doing in lab. Let me point out with the estimation though, do not use that as part of your analysis. The estimation is simply to allow you to check whether your final answer makes sense given what you think the number is in there. And again, what you think is in there is a rough number, so it's definitely not definitive. Good luck, and always, as always, ask me any questions if they come up. Okay, so here are our array of 10 canisters with the electronic balance. So we're going to do each one in turn. We'll start with an empty canister, which is just 0. So here is the mass of an empty canister. Make sure that gets subtracted off all the other masses so you don't factor it into your math. I'll let you decide what to settle on, but everything should be the nearest tenth of a gram. Okay, so let's go to number 1. So as I shake number 1, all right, I get a feel that I'd say there's roughly 15 to 20 that are in here. Okay, so write that down as an estimate or choose a number between there, and there is the mass for number 1. Okay, number 2, definitely lighter weight. As I shake it, I don't know, anywhere from 5 to 10 maybe. Okay. Number 3, maybe a little bit more than number 2, hard to say, maybe somewhere between, I don't know, around 10, maybe closer to 15, maybe a little less than 10. Right. 4 is a heavy one, similar to number 1, so in the ballpark of number 1. Okay, 5, feels like numbers 2 and 3, anywhere from 5 to 10, maybe a little more than 10, but somewhere in there. Okay, 6 is a heavy one. Yeah, it's barely moving anything there, so I would say 15 to 20, 25 maybe. 7, definitely lightweight, probably under 5. 8, it's heavy, 10 to 15, maybe to 20, but probably less than the other ones like 1 or 4. Okay, 9, similar. And lastly, 10 is a moderate weight. Okay, similar to number 2, number 7. Okay, so let me remind you that some of these canisters may have the same number of washers, even though the masses aren't identical, so that introduces a little bit of uncertainty. But your goal now is to figure out how many washers are in each one based on the total masses minus the mass of the canister. Good luck.